You want to explore whether artificial neural networks are able to solve logic tasks. You imagine that you use artificial intelligence to solve logical tasks and to transform the procedure to solve the more ambiguous task of processing natural language. This technique includes AI procedures and is capable of solving logic tasks and processing natural language. Hello universe. This is Zahra M.M.A. Sadiq. Are LSTM networks able to understand logical statements? Are you capable of using AI to process inductive and deductive reasoning? Which network architecture is able to reason and analyze abstract structures? I use an AI-based procedure including LSTM networks to process logical statements and natural language. I use a multi-agent network constellation which processes the tasks in a parallel way. LSTM networks are able to process language and to draw conclusions by using logical reasoning. I use LSTM networks and reinforcement learning procedures to correlate words and sentences. This technique requires the creation of a specific dataset which is suitable for the syntactical, the semantic and the logical processing. Natural language possesses a semantic and syntactic level, and it's also correlated with the logical structure of the statement. The syntactic level refers to the word structure, word order, grammar and grammatical tenses. The semantic level creates hierarchical word clusters of similar words. The similarity between different illnesses indicates a semantic relation. Generic terms and subtopics represent the semantic network. The logical level refers to the relation of different sentences. You derive the suitable treatment of a disease by analyzing the symptoms which the patient experiences and the probability that these symptoms indicate a specific disease and its treatment. The relationship between the symptom and the illness and its treatment is a logical relation. I use this technique to design an expert system. Natural language uses logical operators in an ambiguous form. By transforming this language into formal language, I define the technical meaning of the connectives, or exclusive or and in a precise way. I assure that the model processes similar logical structures in a coherent way. I relate the semantic, the syntactic and the logical graph. The AI-based computation of logic depends on the logical operators of a formalized language. The logical level is disentangled from the semantic and syntactic level. My critics raise the objection that it's possible to process the linguistic and the logical structure without distinction. I separate the linguistic and the logical procedure of natural language. The logical operators and or are conjunctions in a syntactic context. They are not directly related to the semantic level and its clusters. In a legal context, formal language reduces the syntactic ambiguity. I don't restrict the procedure to first-order logic, but extend this procedure and use it in the context of multi-valued forms of logic to define the relations between multi-relational data and to correlate deductive and inductive reasoning. I use a multi-agent system to correlate and separate the semantic, syntactic, and logical procedures. I use the recurrent neural net to process the entailment of logical statements instead of predicting their equivalence. The goal is to define logical relations between conditional statements and to predict relations with a similar semantic structure. LSTM networks possess the ability to understand logical entailment. I assure that the model processes similar logical structures in a coherent way. I separate the linguistic and the logical procedure of processing natural language. I integrate this technique into an expert system.